The National Electrical Code, specifically Section 210.8A in the 2020 edition, addresses ground fault circuit interrupter, or GFCI, protection for receptacles. Understanding these requirements is crucial for electrical safety and code compliance. The previous rule that mandated GFCI protection for receptacles within 6 feet of a sink has been updated with more specific guidelines. The 2020 National Electrical Code now requires GFCI protection for all 125-volt single-phase, 15 and 20 ampere receptacles installed in several locations. These locations include bathrooms, garages, outdoors, crawl spaces, unfinished basements, and importantly, laundry areas. The specific mention of laundry areas in the code is paramount. Any receptacle installed within a laundry room must have GFCI protection. This requirement applies regardless of the distance between the receptacle and any sink within the laundry room. The focus is on the location itself, not the proximity to a water source. The purpose of GFCI protection is to prevent electrical shock. GFCIs monitor the current flowing in a circuit. If there is an imbalance, indicating that current is leaking to ground, the GFCI will trip, quickly cutting off the power. This rapid response minimizes the risk of electrical shock, particularly in damp or wet locations. Now let's delve into the technical aspects of GFCI protection. A GFCI works by comparing the current flowing in the hot or energized conductor with the current returning in the neutral conductor. Under normal circumstances, these currents should be equal. However, if a fault occurs, such as when a person comes into contact with a live wire, some of the current will flow through the person's body to ground. This creates an imbalance between the hot and neutral conductors. The GFCI detects this imbalance and trips the circuit, typically within milliseconds. The threshold for tripping is very low, typically around 5 milliamperes, which is enough to protect a person from a dangerous electrical shock. The installation of GFCIs is relatively straightforward. GFCI receptacles are designed to replace standard receptacles. They have terminals for the hot, neutral, and ground wires, as well as a test and reset button. The wiring connections must be made correctly to ensure proper operation. It is crucial to identify the line and load terminals correctly. The line terminals connect to the incoming power source, while the load terminals connect to downstream receptacles or devices. When replacing a standard receptacle with a GFCI receptacle, it is essential to turn off the power to the circuit at the circuit breaker. This prevents the risk of electrical shock during the installation process. Once the power is off, the existing receptacle can be removed. The wires should be disconnected from the old receptacle and connected to the corresponding terminals on the GFCI receptacle. The ground wire should be connected to the green ground terminal. After the wiring is complete, the GFCI receptacle can be carefully pushed back into the electrical box and secured with screws. The faceplate can then be attached. To test the GFCI receptacle, press the test button. This should trip the receptacle, cutting off the power. To restore power, press the reset button. It is important to test GFCI receptacles regularly, typically once a month, to ensure that they are functioning properly. If a GFCI receptacle fails to trip when the test button is pressed, it should be replaced immediately. In addition to GFCI receptacles, GFCI circuit breakers can also be used to provide GFCI protection. GFCI circuit breakers are installed in the electrical panel and protect the entire circuit. They are often used when it is not feasible to replace all of the receptacles on a circuit with GFCI receptacles. GFCI circuit breakers operate on the same principle as GFCI receptacles. They monitor the current flowing in the hot and neutral conductors and trip the circuit if an imbalance is detected. The installation of GFCI circuit breakers should be performed by a qualified electrician. Working inside an electrical panel can be dangerous, and it is important to follow all safety precautions. When selecting a GFCI receptacle or circuit breaker, it is important to choose one that is rated for the intended application. GFCIs are available in different classes depending on the level of protection they provide. Class A GFCIs are the most common type and are suitable for most residential and commercial applications. They trip at a ground fault current of 5 milliamperes. Class B GFCIs are designed for use in specific applications, such as swimming pools and spas. They trip at a lower ground fault current, typically around 1 mA. It is also important to choose a GFCI that is listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL. This ensures that the GFCI has been tested and meets safety standards. The National Electrical Code is updated every 3 years. It is important to stay up to date with the latest requirements to ensure electrical safety and code compliance. Changes to the code can affect the installation and use of GFCIs. For example, the 2020 National Electrical Code includes new requirements for GFCI protection in specific locations, such as dwelling unit basements with unfinished portions or crawl spaces. These changes are intended to improve electrical safety and reduce the risk of electrical shock. In summary, GFCI protection is a critical safety measure that helps prevent electrical shock. The 2020 National Electrical Code requires GFCI protection for all 125-volt single-phase, 15 and 20 ampere receptacles installed in laundry areas, regardless of the distance from a sink. Understanding and complying with these requirements is essential for ensuring electrical safety in residential and commercial buildings. Furthermore, it is always best to consult with a qualified electrician to ensure that electrical work is performed safely and in accordance with the National Electrical Code. The electrician can assess the specific needs of the installation and recommend the appropriate GFCI protection measures. They can also ensure that the installation is performed correctly and safely. Now, to reiterate some key points about GFCI protection in laundry rooms. Firstly, the 2020 National Electrical Code mandates GFCI protection for all 125-volt single-phase, 15 and 20 ampere receptacles in laundry areas. Secondly, this requirement applies regardless of the distance between the receptacle and any sink. Thirdly, the purpose of GFCI protection is to prevent electrical shock by quickly cutting off power in the event of a ground fault. Fourthly, GFCIs work by monitoring the current flowing in the hot and neutral conductors and tripping the circuit if an imbalance is detected. Fifthly, GFCI receptacles and circuit breakers are available to provide GFCI protection. Sixthly, installation of GFCIs should be performed by a qualified electrician. Seventhly, GFCIs should be tested regularly to ensure proper operation. Eighthly, the National Electrical Code is updated every 3 years, and it is important to stay up to date with the latest requirements. Ninthly, GFCI protection is a critical safety measure that helps prevent electrical shock. Tenthly, always consult with a qualified electrician to ensure that electrical work is performed safely and in accordance with the National Electrical Code. Understanding the specific requirements of the National Electrical Code is essential for electrical contractors and homeowners. A properly installed or missing GFCI protection can create a significant safety hazard. In addition to the requirements for laundry rooms, the National Electrical Code also mandates GFCI protection in other locations, such as bathrooms, garages, outdoors, crawl spaces, and unfinished basements. These requirements are intended to protect people from electrical shock in areas where they are more likely to come into contact with water or moisture. For example, in bathrooms, GFCI protection is required for all 125-volt, 15 and 20 ampere receptacles. This is because bathrooms are often damp or wet, which increases the risk of electrical shock. Similarly, in garages, GFCI protection is required for all 125-volt, 15 and 20 ampere receptacles that are readily accessible. This is because garages are often used for working on cars and other equipment, which can increase the risk of electrical shock. Outdoors, GFCI protection is required for all 125-volt, 15 and 20 ampere receptacles that are accessible to the public. This is because outdoor receptacles are exposed to the elements, which can increase the risk of electrical shock. Crawl spaces and unfinished basements are often damp and humid, which can also increase the risk of electrical shock. Therefore, the National Electrical Code requires GFCI protection for all 125-volt, 15 and 20 ampere receptacles in these locations. In addition to the specific requirements for GFCI protection, the National Electrical Code also includes general requirements for electrical safety. These requirements cover topics such as wiring methods, grounding, overcurrent protection, and electrical equipment. Compliance with the National Electrical Code is essential for ensuring electrical safety in residential and commercial buildings. Failure to comply with the code can result in fines, penalties, and even legal action. It can also create a significant safety hazard for occupants. Therefore, it is important for electrical contractors and homeowners to stay up to date with the latest requirements of the National Electrical Code and to ensure that all electrical work is performed safely and in accordance with the code. It is also important to note that the National Electrical Code is not the only source of electrical safety requirements. Many states and local jurisdictions also have their own electrical codes and regulations. These codes and regulations may be more stringent than the National Electrical Code. Therefore, it is important to check with the local authorities to determine the applicable electrical safety requirements. In conclusion, understanding and complying with the electrical codes is critical for safety. The 2020 National Electrical Code provides specific guidelines for GFCI protection in laundry rooms, emphasizing location over proximity to water sources. Remember that electrical safety is paramount, and consulting with a qualified electrician ensures that all installations are safe and compliant.